Hello everyone, my name is Tasneem Safdari. In the previous videos, I was explaining the questions of the assignment and I have explained first and second questions in the previous videos. So today I'll be going to explain the question number 3. If you wish to understand or look to those questions, you can visit my page for it. So let's start with question number 3. In today's video, I'll be explaining only the question number 3 and the rest of the questions in different parts of the video, in different videos. So question number 3, explain the purpose of training, test and validation sets in machine learning. What is cross-validation and how does it differ from a simple train validation test split? So machine learning datasets are usually divided into 3 parts to ensure that the model learned is both accurate and generalized. So datasets are divided into 3 parts so that the model which we have learned is both accurate and generalizable. So the 3 parts are the training set, validation set and test set. So let's understand this one by one. So first is training set. What is the purpose of training set? Used to train the model. The algorithm adjusts its parameter weights by learning patterns in this data. Example, if you are training a decision tree, the training set is used to build the structure of the tree. So it is basically building the structure of the tree. So this is the example of a training set. Validation set, used to tune hyperparameters. Example, depth of a tree, learning rate, k in knn. Second, helps prevent overfitting by checking how well the model performs on unseen data during training. And third, used for model selection, choosing the best model amongst many. Example is, you train multiple models with different hyperparameters and choose the one that performs best on the validation set. So you train multiple models with different hyperparameters. There are different hyperparameters and choose the one that performs best on the validation set. Third is test set. Used only after training and validation are completed. When training is done, validation is done, then training set comes. Provides an unbiased evaluation of how well the final model will perform on real world data. So we have a real world data and it performs unbiased evaluation on it and gives us a final model on how well it is performing on real world issues, real world data. Third is, helps estimate the true generalization error. What are the important? The test set should never influence the training process or hyperparameter tuning. Then what is cross-validation? Cross-validation is a technique to evaluate model performance more reliably, especially when data set is small. So cross-validation, as the name suggests, that it is a technique through which we are evaluating the performance more reliably, especially when the data set, we have a small data set with us. Most common is k-fold cross-validation. So it is the most common validation technique. The data set is split into k equal size fold. So k is a constant and we divide the data sets in k equal sized folds. For each iteration, one fold is used as validation and the remaining k minus 1 folds are used for training. So we have k folds now with us. So one fold is used as validation and the remaining k minus 1 are used for training. The process is repeated k times, each time with a different fold as a validation set. So we repeat it k times and every time uh, each time the different fold is treated as validation set. If the starting 1 is the validation set, then next time 3, 4 or any number, so this is repeated k times, and every fold get a chance to become the validation set. The final performance is the average accuracy or error across all k runs. Why use cross validation? Reduces variance from a single train or validation split. Uses all data for both training and validation at different times. So at different times every model can be used at both training and validation. Provides a more robust estimate of model performance. You'll get a more robust estimate. Now difference between train validation test split and cross validation. So in train validation test split, there is a single split, fixed training validation test set. Whereas in cross validation, rotation validation, every sample becomes validation once. Now reliability. In train validation test split, more variance depends on how data was split. And in cross validation, more stable, low variance. Now good for train validation test split is good for large data sets because it cannot be split into k times and every time we have to repeat the iteration k times. But cross validation is good for smaller medium data sets. Hyperparameter tuning done on the validation set in test validation test split, it is done on validation set, and in cross validation done inside the cross validation loop. Final evaluation on the test set and in cross validation after selecting model test set is used once. So this is the difference between train validation set and cross validation set. In train validation test split, we get we have only one fixed validation test set, and in the cross validation every sample becomes validation, and in train validation it is used for large data set, and in cross validation it is used for small or medium data sets. Now summary. Training set it teaches the model. Validation set tunes hyperparameters, prevents overfitting. And test set final unbiased evaluation, it gives the evaluation which is unbiased, that it tests that a particular how it is performing on the real data, on the real world data. Now what is cross validation? Rotates validation across data to get a more reliable performance measure, especially useful for small data sets. So this was the explanation of question number 3 of the assignment, and here it ends. So in this video I tried to explain the question number 3 in the best possible way. So if you want to look for more and in the next videos I'll be explaining the question number 4, 5th and so on in different videos which you can look up to my channel. Thank you so much.